A discovery revealed that a parchment fragment that had about 74% as much carbon-14 radioactivity as does plant material on the Earth today. Estimate the age of the parchment. To solve this problem, we need to know what the half-life of carbon-14 is. In carbon dating community, this is a well-known fact, but we can look it up. The half-life of carbon-14 is 5,730 years. The half-life model is the amount at any time t equals the initial amount times 1/2 half-life t over the time it takes the substance to reduce its mass or amount into half. In this case, we don't know what the initial amount is, so we would leave it at a sub-zero, 1/2 t, but the half-life is 5,730. Now, we were told that 74% as much carbon-14 radioactivity as does plant material on the Earth today, and that is the percentage that it had left. And so, we assume that we start out with 100%. What is left with that initial 100% is now 74%. Alternatively, we can start with one amount and end up with 0.74. And so the starting amount is irrelevant in this case because we know the percentage. The percentage tell us that 74% of 100 is 74, 74% of 1 is 0.74, and so on. We use 100 for convenience. To isolate t to find out the time, we would first need to divide it by both sides by 100. We end up with 0.74 equals 1/2 raised to the power t over 5,730. We then ln both sides of the equation because the unknown variable is in the exponent. The left-hand side is ln of 0.74, and the right-hand side is now t over 5,730 times ln of 0.5, or 1/2. Isolate t, we would multiply 5,730 to both sides of the equation and divide by ln of 0.5. And so t by itself is 5,730 times ln of 0.74 divided by ln of 0.5. We then input this into a calculator and obtain t to be approximately 2,489. This is the number of years. And so the age of the parchment is roughly 2,500 years. For a practical purpose, we don't want to be accurate up to the number of years because this is only an estimate. It is okay to say that the age of the parchment is about 2,500 years, which is 25 centuries old.